So today we are, yesterday we did mean, median, and mode. So you've done mean, median, and mode for a long time. And whew. All right, there we go. Just a little noisy today. All right. You guys have done mean, median, and mode for a lot of years. So hopefully that was easy and you did just fine on that. Have you ever heard of mean absolute deviation? No. Good. So this is new. But the nice thing is it builds on what you already know, which is how to take an average. Add a bunch of things up and divide by the number of data points. So mean absolute deviation, also known as MAD, is a measure that gives the average, a measure that gives the average distance of each data point, each data value to the mean. Now, it's kind of an interesting thing. I've actually never used it before, but it's kind of a stepping stone to some higher statistical formulas that we use, which is standard deviation. So this is sort of a stepping stone. And what it's doing is it's saying how far away we are from the average value. And so we want to, and it's just good to see how much that the smaller the number, the closer our data is to an average. Like it's just a nicer average, okay? And so in order to find the mean absolute deviation, the first thing is we need to find the mean. All right? The mean, and I'm just going to write average. All right. So you're going to add up your original numbers and divide just like we did yesterday. And then what we have to do is find the distance. Find the distance of, I'm going to say the distance between the data point and the mean. We want to find the distance between those two values and then average these distances. Mean absolute deviation, or mean absolute distance, is another way to think about it. Average these distances. So there's a couple of steps here, but it's not too bad. So the first thing we're going to do, example 1 here, data set A. We want to find the mean absolute deviation for data sets A, B, and C, round to the nearest tenth if necessary. So first of all, I want to find the mean of our data set. How do I find the mean of our data set? Add each of these together and divide by 5. All right, so here we go. We're going to add these up. 1 plus 3 plus 5 plus 14 plus 17. We get 40. So this is 40 divided by 5, which is 8. Okay. So we found our mean, so that's pretty easy, not too bad. What we need to do for step 2 is find the distance between the data point and our mean value. So I want to know if my mean value is 8, my data point is 1. What's the distance between 8 and 1? 7. How'd you get 7? You subtracted. Yep, that's all we have to do. We're going to subtract. What is 8 minus 1? 7. Good. So I'm going to take the 7. And I need to use my next data point. What's the distance between 8 and 3? 5. How do we get 5? Subtract. It's just 8 minus 3. We get 5. All right, my third data point. What's the distance between 8 and 5? 3. Okay, 8 minus 5 is 3. All right, 8 and 14. What's the distance between 8 and 14? 6. All right, and then 8 and 17. What's the distance between 8 and 17? 9. How did you get 9? You just subtract 17 minus 8. So when we find the distances, we're really just subtracting our value, our data point, and the mean. All right, so now those are all of our distances, and we're going to divide to find the average. We're going to divide by 5 again. So this is our MAD. So I'm going to do 7 plus 5 plus 3 plus 6 plus 9. And I get 30 divided by 5, which is 6. All right, so the MAD is 6. Okay. All right, let's try another. So data set B. Let's see, there are 1, 2, 3, 4, 5 values here. So what's the first thing we need to do? Add them and divide. So let's see, 5 plus 6 plus 8 plus 9 plus 12. And we get 40 over, how many data are there? 5, okay. So 40 over 5 again happens to be 8, all right. So my mean is 8 of this data set. Now I need to figure out my MAD, my distances between. What is the distance between 8 and 5? 3. How do we get that? Subtract. 8 minus 5 is 3. All right. What's the distance between 8 and 6? 2. 8 minus 6 is 2. What's the distance between 8 and 8? 0. Very good. All right, everybody now, what's the distance between 8 and 9? 1. What's the distance between 8 and 12? 4. All right. And then we're going to end up dividing by 5 again. All right, so 3 plus 2 plus 0 plus 1 plus 4. So that is 10 divided by 5, and we get 2 for our MAD values. You'll notice the difference in these two numbers. 6 is pretty big in comparison to 2. And what that tells me is data set B is very close. All those data points for data set B are a lot closer to the average. So the data is a lot closer together. And this data set A is a lot more spread apart. So it's not as good of a measure. Okay. Oh, interesting. Let's see what happens here. All right, data set C, we have, 8, 2, 3, 4, 8, 5. So that's 40 over 5, which again is 8. Oh, interesting. Okay, so there's our mean is 8. And if I want to find my distances between now, what's 8 minus 8? 0 plus 0 plus 0 plus 0 plus 0, all divided by 5. What do we get? 0. Hey, the MAD is 0 on data set C. Holy moly, that's interesting. Well, what does that mean? There's no difference between the values and the mean. They're all this, oh wow, those are really close together, aren't they? All right, so interpreting the mean absolute deviation is the closer the MAD, mean absolute deviation, is to 0, the less variation there is in the data. So what that means is the closer we are to 0, the better our data is. The data is a lot closer to the average value, the mean. All right. We haven't talked about outliers, but we're going to just do one here more, I think. I'll talk about outliers later. Alright, so directions: find the mean absolute deviation of each data set, round answers to the nearest tenth. The speed in miles per hour of Will's last 6 pitches are as follows. What do we do first? Find the mean. Yeah, we're going to find the mean. We don't have to put them in order to find the mean. So we're going to start by adding everything up. 71 plus 78 plus 75 plus 74 plus 80 plus 72. So I'm adding up all of my data here, and I get 450 divided by how many 6 pitches. So we're going to take that and divide by 6, and I get 75 for the mean. All right, now to calculate the MAD, mean absolute distance here. We have a mean of 75. What's the difference? What's the distance between 75 and 71? 4. The distance is 4, or the difference is 4. All right, what's the difference between 78 and 75? 3. 75 and 75? 0. 74 and 75? 1. Very good. 80 and 75? 5. And 72 and 75? 3. Very good. And we're going to divide that by 6. So again, I'm just going to add up my numerator here. I get 16 divided by 6, and that is 2.67, or just 7. All right, 2.7. So pretty close. All right. Let's turn the page and just do one more. I think we're good. Are you getting it? Is that fine? This is statistics. This is just following formulas. That's all statistics is. Like, everything has a formula, and you just have to learn how to use the formula. All right, let's look at we're just going to look at number 3, because I don't want to do the ones with large numbers that make me work harder. All right, first things first, we're going to find the mean. Weight in ounces of packages on a mail truck. 5 plus 24 plus 15 plus 35 plus 9 plus 14. I get 102 over. How many packages are there? 6 packages. So we get 17 for our mean value. Now to calculate the MAD, mean absolute deviation. Deviation is like how far it changes. That's what it means. So, all right. Now the absolute deviation. What's the change between 7 and 5? 12. 17. What's the distance between 17 and 24? 7. Very good. And the distance between 17 and 15? 2. Oh, 17 and 35? 18. Very good. The distance between 17 and 9? 8. Very good. And the distance between 17 and 14? 3. Very good. Again, that's going to be divided by 6. So I'm going to add up my numerator first. 12 plus 7 plus 2 plus 18 plus 8 plus 3. We get 50. Make sure you do this correctly. You have to do the numerator first. Divided by 6, we get 8.3 for the mean absolute deviation. Okay, do you have questions for me? All right, you guys have adults math.